Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we're going to solve systems of linear equations in three variables. How do we do this? Well, first, we reduce the system to two equations and two variables by using the addition on two of the equations. Then we're going to solve the two equations from both variables by using addition or substitution. We're going to substitute these two variables into one of the original equations to find the value of the third variable, and then we're going to check our solutions. All right, let's do an example. Here we have x minus y plus 3z equals 8. We're going to call that equation 1. We have 3x plus y minus 2z is negative 2. We're going to call that equation 2. And we have 2x plus 4y plus z equals 0. And we're going to call that equation 3. Now we need to decide which variable to eliminate. And you can choose any variable you want to. I'm going to choose y. Now if you look at equation 1 and equation 2, if you add those two together, then your y goes away. So I'm going to circle my equation number. So I'm going to add equation 1 to equation 2. So I have x minus y plus 3z equals 8. And I have 3x plus y minus 2z equals negative 2. And when I add, I get 4x plus z equals 6. And I'm going to call that my equation 4. Next, I am going to look at equation 1 and equation 3. So if I have a negative 4y in equation 1 and a positive 4y in equation 3, then when I add those together, it goes away. So in order to do that, I'm going to need 4 times equation 1 plus equation 3. So 4 times equation 1 is 4x minus 4y plus 12z equals 32. Equation 3 is 2x plus 4y plus z equals 0. And when I add, I get 6x plus 13z equals 32. And this is my equation 5. Now I'm going to put equation 4 and 5 together. 4x plus z equals 6. And 6x plus 13z equals 32. And I'm going to solve here for x and for y. So it's going to be easiest if I multiply the first equation by negative 13 and I can eliminate the z's. So when I do that, this 4x plus z plus 6 becomes negative 52x minus 13z equals negative 78. And the 6x plus 13z equals 32 remains unchanged. When I add, I get a negative 46x equals negative 46. So x is going to be 1. And then I can find z by substituting here. 4 times 1 is 4 plus z equals 6. And if I subtract 4 from both sides, z is going to be 2. Now I need to find y. It's going to be easiest to go back to equation 2. 3 times x, 3 times 1 is 3, plus y. Z is 2, so 2 times 2 is 4, equals negative 2. So I have y minus 1 equals negative 2, or y equals negative 1. So the solution is my ordered triple, 1, negative 1, and 2. We have 2x plus y minus 2z is negative 1. That's our equation 1. We have 3x minus 3y minus z is 5. That's our equation 2. And we have x minus 2y plus 3z equals 6. That's our equation 3. And we want to eliminate a variable. So let's just choose z. So if I look at equation 1 and equation 2, or let's look at equation 1 and equation 1, equation 2. If I need, in equation 2, I need a positive 2z. So I need to multiply that second equation by negative 2. So I'm going to have equation 1 plus a negative 2 times equation 2. So equation 1 will not change. Equation 2 will become negative 6x plus 6y plus 2z equals negative 10. And when I add, I'm going to have negative 4x plus 7y is negative 11. And I'm going to call that equation 4. The next, I'm going to look at equations 2 and 3. And if I do 3 times equation 2 and I add to equation 3, then my z's will go away. So I'm going to do 3 times equation 2 plus equation 3. So my equation 2 will become 9x minus 9y minus 3z is 15. I copy my equation 3, x minus 2y plus 3z is 6. And when I add, I get 10x minus 11y equals 21. And this is my equation 5. Now put equation 4 and equation 5 together. Negative 4x plus 7y is negative 11. And 10x minus 11y equals 21. And I'm going to choose to eliminate the x's here. So if I look at 4 and I look at 10, the least common multiple is 20. So in order to make a negative 20 in our first equation for x, I need to multiply by 5. And in my second equation, I need to multiply by 2. So the first equation multiplied by 5 gives me negative 20x plus 35y equals negative 55. And my second equation multiplied by 2 gives me 20x minus 22y equals 42. When I add, I'll get 13y equals negative 13. So y is negative 1. And if y is negative 1, I can find x. I'm going to go here to find x. Negative 4x. Negative 7 or negative 1 times 7 is negative 7 equals negative 11. So negative 4x, if I add 7 to both sides, I get negative 4. So x is going to be 1. So now I need to find z, and I'm going to go here. 3x, so 3 times 1 is 3, minus 3 times y is negative 1, will be positive 3, minus z equals 5. So negative z, if I subtract 6 from both sides, it's going to be negative 1. So z is 1. So my solution set is the order triple 1, negative 1, and 1. Let's look at another one. We have x plus z equals 3. That's our first equation. We have x plus 2y minus z is 1. Second equation. And we have 2x minus y plus z is 3. Third equation. So we're going to choose here to eliminate z. So if I add equation 1 and equation 2, I have x plus z equals 3. I have x plus 2y minus z equals 1. And if I add those two together, I get 2x plus 2y equals 4. And that's my equation 4. Now, if I add equations 2 and 3 together, my z will go away. So I have x plus 2y minus z equals 1. And 2x minus y plus z equals 3. So when I add that together, I have 3x plus y equals 4. And that's my equation 5. So let's put equation 4 and equation 5 together. We have 2x plus 2y equals 4. And we have 3x plus y equals 4. So if I choose to eliminate my y's here, if I multiply the second one by negative 2, my first one stays the same. Negative 2 times my second equation here is negative 6x minus 2y equals negative 8. When I add, I get negative 4x equals negative 4. So x is positive 1. I need to find my y value. So I'm going to go here to find my y value. 2 times x is 2, so 2 plus 2y equals 4. If I subtract 2 from both sides, 2y is 2, or y is 1. Now I have to find my z, and I'm going to go here. X, which is 1, plus z equals 3, so z is 2. So my solution set is to order triple 1, 1, 2. So remember that Dr. LB is always in. Please come back for more math help.